Hello everyone, and welcome back to the channel. If you've been enjoying these videos about the universe, feel free to leave a like. It really helps me grow the channel, and I truly appreciate it. And if you've just come out of the holiday season, I hope you all had a peaceful and relaxing time with the people you care about. Today, we are going to explore one of the most beautiful, mysterious, and quietly mind-bending ideas in modern cosmology, the cosmic horizon, the ultimate limit of what we will ever be able to see in the universe. We often talk about the edge of the universe as if it were a wall, a physical border, a place where space simply stops. But that isn't what cosmologists mean. The real edge is stranger. It's not a solid barrier. It's a limit created by time, light, and the expansion of space itself. And to understand it, we first need to step back and ask a very simple question. When we look into the night sky, how far are we actually seeing? Because every point of light in the sky is a message from the past. Light doesn't arrive instantly. It travels. It takes time. And the farther away something is, the further back in history we are looking when we observe it. The moon? About 1 second in the past. The sun? Roughly 8 minutes ago. The nearest big galaxy, Andromeda? More than 2 million years into history. But when astronomers look deeper, much deeper, they see light that has been traveling for billions of years, so far back that we are observing the universe when it was young, small, and unfamiliar. And because light has a finite speed, there is a maximum distance from which light has had time to reach us since the beginning of the universe. That distance defines what we call the observable universe. Here's the surprising part. The observable universe isn't centered on some cosmic origin point. It's centered on you, or more precisely, on the position in space where you are right now. And someone in a distant galaxy, billions of light years away, has their own observable universe also centered on them, overlapping with ours only partly. So already the story becomes stranger than most people expect. But there is another layer, and this is where the idea turns from interesting to deeply profound. Because the universe isn't static, it's expanding. Not like an explosion spreading matter through empty space, but like space itself growing, carrying galaxies along with it. And this expansion changes everything about what we can see, not only today, but forever. Some galaxies are already so far away, and moving away so fast due to expansion, that the light they emit right now will never reach us. Not in millions of years, not in trillions, not ever. That invisible boundary, beyond which new light is permanently lost to us, is called the cosmic event horizon, and it marks the true edge of what is ultimately knowable. It doesn't block light. It doesn't push anything back. It simply exists because space stretches faster than light can cross it. And here is the part that feels almost emotional. Most of the galaxies we can see today will eventually slip beyond that horizon. They will continue to exist, forming stars, colliding, evolving, but their light will never reach the Milky Way again. In the unimaginably far future, the night sky will grow emptier and emptier, until only the closest galaxies remain gravitationally bound to us. The rest will fade into eternal darkness. It means that the universe we see today is temporary, a cosmic snapshot, a brief moment where the sky is still rich with distant light, and that realization changes the way many astronomers think about existence. Because there are regions of the universe, vast, real, physical, that are already and permanently beyond our view. Not because telescopes are weak, not because we lack technology, but because of the way space-time itself behaves. And perhaps the strangest truth of all is this: the observable universe is not the whole universe. It may only be a tiny fraction of something far, far larger. To understand the cosmic horizon more clearly, we have to think about light not as a simple beam, but as information traveling through stretching space. When the universe was young, galaxies were much closer together. As space has expanded, the light they released has been stretched too, changing its color. This stretching is called redshift, and it tells us how fast a galaxy is moving away. The greater the redshift, the faster the separation rate. But at extreme distances, something surprising happens. Space can expand faster than light can cross it, meaning the information being sent can never arrive here. From our perspective, those galaxies appear to slow, fade, and eventually vanish into darkness. They still exist, but their light is lost to us forever. This is not a dramatic boundary like the edge of a cliff. It is a quiet, mathematical limit created by the geometry of space-time itself. As the universe continues to expand, more and more distant galaxies will pass beyond this horizon. The night sky will slowly become emptier over time. Future astronomers, living trillions of years from now, may see only their local group of galaxies and assume that the wider universe never existed yet. We are fortunate to be alive in a cosmic era where the sky is rich with distant signals, giving us a glimpse of the reality. To see why this horizon exists at all, we have to return to the beginning, to the moment when the universe was far hotter, denser, and smaller than it is today. In that early age, light could not simply travel freely. Space was filled with charged particles that scattered every photon, turning the young cosmos into a glowing fog. Only when the universe cooled enough for atoms to form did light finally break free and begin its long journey. What we see today as the cosmic microwave background is that ancient first light, stretched and cooled by billions of years of expansion. From that moment onward, galaxies began to assemble, stars formed, and structure slowly emerged from the initial smoothness. Yet, while matter was gathering locally, space itself kept expanding everywhere. This delicate balance between gravity pulling inward and expansion pushing outward created the cosmic landscape we observe today. And hidden within that balance is the reason some regions are lost to us forever. Imagine a message leaving a distant galaxy billions of years from now. Even if it travels at the speed of light, the space it must cross will keep stretching, always adding distance faster than the message can overcome. From our point of view, that galaxy fades not because it disappears, but because space has outpaced information itself. The horizon marks the point where communication ends, and that idea raises a deeper question. If we cannot see those regions, do they still count as part of our universe, or are they something forever separate from our story? For most of human history, people imagined the universe as a fixed stage, silent and eternal. Stars were thought to shine forever, unchanging and permanent in the sky. But modern cosmology paints a very different picture. The universe is dynamic. It evolves. Structures form, collide, dissolve, and vanish beyond reach as space continues to stretch. If someone were to watch the cosmos for unimaginable spans of time, they would see distant galaxies slowly dim, then fade below visibility, until nothing remained except a few nearby companions. To those future observers, the universe would look small, local, and lonely. They might never guess that, once, the sky was filled with distant light from billions of galaxies. This raises an almost poetic idea. We do not simply live in a place within the universe, we live in a particular time in the universe, a brief era when the cosmos is still readable. Today, by studying faint, ancient light, we can reconstruct the cosmic story from its earliest chapters. But in the deep future, that evidence will be gone forever. The cosmic horizon will erase the wider picture, not by destroying anything, but by hiding it beyond a boundary no signal can ever cross. Right now, every telescope we build is racing against that future. We are gathering the last wide-angle view of the universe before the sky quietly closes in. And that makes our moment uniquely precious. We are witnesses to a universe that is still open, still visible, still full of messages from unimaginable distances. One of the most surprising aspects of the cosmic horizon is that it is not fixed in space like a distant wall. It is different for every observer in the universe. A galaxy billions of light years away has its own horizon, shaped by the same laws of expansion, but centered on its position instead of ours. What is visible to them may not be visible to us. From their perspective, we are the ones who might one day fade beyond reach. Every observer carries their own bubble of what can, in principle, ever be known. This idea tells us something profound. There is no single universal view of reality that every civilization could share. Each world is surrounded by its own shrinking window onto the cosmos. And yet, within that window, the same physical laws apply everywhere. Gravity, relativity, quantum mechanics, and the structure of atoms all appear consistent across the universe we can see. So, although our horizons are separate, the script of nature seems universal. The unseen regions are not magical or different. They follow the same rules. We simply cannot receive their story. In a sense, the cosmic horizon defines the boundary not only of what we can see, but of what we can ever verify. Beyond it lies speculation, mathematics, and imagination, but never confirmation. This humbling limit reminds scientists that even our best theories are built from a partial view. We model the whole universe using only the fraction still inside our fading window. And yet, that fragment has already revealed more than anyone in history dared to imagine. It shows a universe vast beyond comprehension and governed by elegant, measurable laws. So, what does the cosmic horizon really mean for us? It reminds us that the universe is not just large. It is larger than what cause and effect will ever allow us to experience. There will always be places that remain invisible, unreachable, and silent, no matter how advanced our technology becomes. Light itself is limited by the structure of spacetime, and yet, inside our small, observable bubble, we have already uncovered the history of stars, galaxies, and the birth of matter. We have mapped billions of light years using faint whispers of ancient light. That is extraordinary. We are tiny beings, living on a small planet around an ordinary star, but we have managed to measure the shape and age of the cosmos. When we talk about the horizon, it can sound like a restriction, a reminder of what we will never know. But it is also a celebration of everything we have discovered inside that shrinking window. Right now, our instruments are the most powerful eyes the universe has ever given itself. Through us, the cosmos observes its own structure and asks questions about its origin and fate. One day, distant galaxies will fade from view, but the knowledge we gather today will endure, written into the memory of whatever life still exists to read it. So as we look into the night sky, we are not just staring into space. We are looking across time, toward the very limits of what reality will ever allow us to witness. And that makes this era, our era, uniquely precious. For a brief moment in cosmic history, the universe is still visible, and we are here to see it.